Today, we're going to dive into one of the most powerful, life-giving weather phenomena on the entire planet, the Indian monsoon. In this explainer, we'll see how this single, massive force of nature doesn't just bring the rain, it literally builds an entire world. Okay, just look at this. On the left, you've got this dry, kind of parched landscape in late May. Then, boom, on the right, the exact same spot just 3 months later, and it's a lush, green paradise. Now, this isn't magic. It's the work of one of the most powerful forces on the entire planet. So the big question is, what is it, and how on earth does it do that?
To get that answer, we've got to first understand the massive climate engine that's running the whole subcontinent.
So, there are a few key players that really set the stage. First up is latitude. The Tropic of Cancer slices right through the middle of the country. Then you have the Himalayas, which act like this gigantic wall shielding India from those freezing northern winds. And finally, its super long coastline means the ocean has a huge say in what happens. But out of all those factors, the most dynamic one, the part that truly powers this whole engine, is the constant push and pull between that vast landmass and the ocean all around it. It all kicks off with a really simple principle. During the day, land heats up way faster than the sea. This hot air over the land rises, and that creates low pressure. So, to fill that gap, cooler, high-pressure air from the ocean just rushes right in. We all know this as a sea breeze. And then, at night, the whole thing just flips. The land cools down faster than the water, so the cooler air flows from the land back out to sea. That's a land breeze. Simple, right? Okay, now hold that thought, because we're about to scale this concept way up. And that brings us to our main character, our protagonist. Because the Great Indian Monsoon is basically that same sea breeze system, just blown up to a continental epic scale.
So here's the crucial thing to get. The monsoon isn't just rain. At its very core, it's a massive seasonal wind reversal. In the summer, the Indian landmass gets incredibly hot, creating this enormous low-pressure zone that starts pulling in just immense amounts of moisture-packed air from the Indian Ocean.
And right here, you can see that incredible journey begin. Starting in late May, these powerful winds, the southwest monsoon, begin their march across the subcontinent. As they travel over thousands of kilometers of warm ocean, they are just soaking up an unbelievable amount of water. Now, when this massive wind system hits the tip of the Indian Peninsula, it literally splits in two. You've got the Arabian Sea Branch, which slams into the western coast, forcing all that moist air up over the mountains and dropping just tons and tons of rain. Meanwhile, the Bay of Bengal Branch sweeps north, bringing all its moisture to eastern and northeastern India. Then, by September, the whole engine just goes into reverse. The land starts to cool down, creating high pressure, and the winds switch direction, blowing from the northeast back out to sea. This is what's called the retreating or northeast monsoon, and it marks the end of the rainy season for most of the country. Okay, so we have this enormous water pump cycling through the year. What does all that water actually do on the ground? What does it create? Well, have a look at this rainfall map. The path of those two monsoon branches we were just talking about directly creates this pattern. See the dark green along the west coast and up in the northeast? Those are the areas that get absolutely hammered with rain. We're talking over 200 centimeters a year. Then notice those pale yellow zones in the interior and the northwest. They get less than 50 centimeters, a huge difference. Now keep that rainfall pattern burned in your mind for a second, because when we bring up this map of India's natural vegetation, wow, the connection is it's undeniable. It's almost a perfect match. So this is the key takeaway. The dark green, high rainfall areas on that first map, they correspond exactly to the dense, tropical evergreen forests you see here. The lighter green areas match the monsoon or deciduous forests. And those yellow rainfall zones, they support thorn forests. The monsoon is literally the architect of the entire landscape. And of course, where you have different landscapes, you get different kingdoms of wildlife. These vegetation zones, carved out by the rain, they become these unique habitats for an absolutely incredible array of animals. The connection is so direct. In those super wet tropical evergreen forests, that's where you'll find the lion-tailed macaque. Where there's a bit less rain, in the deciduous forests, that's the kingdom of the Royal Bengal tiger. Then, in the much drier thorn forests, you get the Asiatic lion. And in almost desert-like conditions, unique animals like the Indian wild ass have found a way to survive. Let's put a face to some of these habitats. Here is the majestic Royal Bengal tiger, an animal that's perfectly adapted to that cycle of wet and dry seasons in India's deciduous monsoon forests. And here, in the regions that get the most intense monsoon downpours, the evergreen forests of the Western Ghats, you find these specialized creatures, like the beautiful lion-tailed macaque. The sheer diversity, from the striking great Indian hornbill to countless other species, is a direct result of the variety of homes the monsoon creates. It's an entire web of life, all powered by these seasonal rains.
So let's bring this all home. What we really have here is this astonishingly interconnected system, a chain reaction that all starts with the sun heating the land.
The monsoon isn't just a weather event. It's the absolute backbone of agriculture for over 1 billion people. It's deeply woven into cultural festivals and traditions, and as we've seen today, it is the lifeblood that sustains the subcontinent's incredible ecosystems.
And that brings us to our final thought here. For thousands of years, this rhythm has been predictable. It's been reliable. But we now live in an age of really rapid climate change. So the question we're left with is, what happens to this whole incredibly delicate system, from the farms to the forests to the tigers, if the very heartbeat of the monsoon starts to weaken, if it starts to falter?